All right. So first, I'd like to see if you guys have any questions before I go ahead and do the review. Do you have any specific questions you want to ask? Right? You guys can hear me, right? All right. Okay, so I'm gonna share my screen. So in the beginning of the semester, I mentioned that the whole semester course will be related to this one image in here. So now if we go back to this image, I hope you have a better understanding of the whole process of the statistical analysis. So anytime when you conduct a study, there's always going to be a population of interest, right? So what do you want to study? What's the group that you want to study of? That's your population, right? And then you're always going to have a group called a sample. So the population size is too large most of the time. If you want to get some evidence, basically data collected, it's not practically possible to collect data from the entire population. So instead, we need to pick some individuals out as our sample, and data will be collected from there. But the thing is, the sample is only a small portion of the population. Then how are you supposed to take the individuals out so that your sample is a good representative of the population, right? So that's related to a term called a sampling process. So sampling process is about how do we take individuals out from the population, right? And now we learn a little bit about the sampling, right? The most important keyword is we need to make sure we do a random sample, right? So make sure all the individuals are randomly selected, right? That way, the chance of being biased will be a lot lower than if you don't do random sample, okay? So then once the data is collected, then you can study it, right? We can describe the data. We can try to observe some trend or some, features from the data. So we need to do a descriptive statistic. So descriptive statistic is basically a process to describe the sample. So from the sample data, what trend or feature can we observe, right? So in that case, we can do two different ways. One is using graph, right? So you can draw pictures like bar chart, pie chart, histogram, stem plot, box plot, scatter plot, right? So different charts are used to describe different kind of features of the data. Then we can also calculate values to describe that feature. So we can calculate some special numbers. And each of the special number will represent a feature of the data. For example, we can calculate sample mean of the sample. That's like the center of the data. We can calculate sample standard deviation. That will be the spread of the data. We can calculate sample correlation. That will be the relationship, of the two variables in the data. And we can also calculate the regression coefficients, right? So to determine, what specific linear relationship the data, the two variables will follow from the sample. Okay, so all these are descriptive statistics. You can describe using graphs, very, intuitive. You can see the features with your eyes, right? Or you can calculate some values, but that needs some more understanding of what each value represent. Okay. But they both have their advantage and the disadvantage. So the graph is intuitive, but it doesn't really have very good accuracy, because when you look at something, when you're viewing some trend, it's hard to determine, which is stronger, which one's weaker by just looking at it. But, if we quantify the measure, then we can compare the number very easily. 2 is bigger than 1, right? So, and then in the end, After you describe your sample, you know exactly what's going on in the sample, but that doesn't address your research question because the research question is always about the population. Then we need a process to draw conclusions about the population, and that process is called inferential statistic. Okay? So in statistic, we have two branches. One is descriptive statistic, only focus on describing a sample, and one is inferential statistic, that will be more advanced, that will refer back to the population. Okay? So in inferences, there are two major types of inferences. One is confidence interval, and the other is hypothesis test. So we learned both of them. In confidence interval, we're trying to estimate something in the population. So you don't know what the population feature will be, what that measure will be for the entire population. For example, mostly we talk about population mean. So what will be the average of the entire population? Can we estimate it? And that process will be a confidence interval. On the other hand, if someone make a claim about a population measure, and you want to see if that claim is being true or false, so assessing a claim, so that process will be going through a hypothesis test, okay? And then for confidence interval and hypothesis test, of course, you have different kind of processes for each of the, approach. So for confidence interval, we learned T confidence interval and the Z confidence interval, basically using different distributions, Z distribution, T distribution. And then for hypothesis test, we have a few different scenarios we talked about. We have one sample Z test, one sample T test, paired sample T test, and then two sample independent T test. That's pooled variance T test, okay? So then in order to do the inferences, we're gonna need a distribution. We need to know what the Z distribution is. We need to know what the T distribution is. If you wanna learn some other statistical inferences using other statistic, you need to learn other distribution as well. There are many, many different distributions from statistic. So we learned a few distributions: Z distribution, T distribution, binomial distribution, right? There are others like F distribution, chi-square distribution. Just different distribution will be applied in different kind of field when you try to do different kind of analysis. So then we need to learn some basic knowledge of probability and distribution. So we need to know what a probability is and what kind of rules can we apply in probability. We have learned 5 different rules, right? And then if you know what a probability is, now we can go to distribution. There are some known famous distribution that's commonly used. So we learned binomial distribution, we learned normal distribution. So then we have the whole loop completed. We start with the population, and then we'll go through the whole process, and we'll go back to the population. And that completes your, any kind of statistical analysis. So at this point, you should be able to read any research paper with statistic in it, even though you're not familiar with their, approach, their model, but you should be able to see the whole design of the study. So, for reading a paper, first identify the population, and then see how they design a study. Is this an observational study or is this an experiment? That will tell you, how you're gonna believe it in the final results. We wanna know, we wanna do an experiment, right? But a lot of times, it's very hard to design an experiment just because, you can't randomly assign treatment to the subject in the study. In that case, it has to be observational study. And then see how the samples are collected, right? Is it really a random sample or not random sample? And we know we wanted to have a random sample, but sometimes that's out of control as well. And then, describing the data is easy. You can see all different kind of chart, or they can calculate some numbers. You can get some ideas. And then whatever the hypothesis is, they're gonna state it in the paper, what they're trying to prove. And then you're gonna see a p-value. So based on the p-value, you can decide either reject the null or fail to reject the null, right? And that's basically for any research paper. One thing you need to pay attention is, what alpha do you choose for the research paper? Most of the paper using 0.05. By the way, now we're not supposed to use 0.05 all the time. It really should depend on what's the consequence of making one or the other type of errors, right? So which error are you more concerned of? You need to pay attention to reduce the error of concerns, right? So in that case, you should choose different alpha values for different study. It's not universal for 0.05 for everything. But in class, we still use 0.05, right? It's kind of contradicting to that belief. But you just need to understand what that is. Okay. So now we're going to go through a little bit in details. So we're going to start from the beginning and try to quickly go through everything. And we're going to keep referring back to this image. So we're going to start from descriptive statistic, right? Okay, so I'm going to talk and write at the same time here. So descriptive statistic. So basically, we know descriptive statistic, we're trying to describe the sample. So we're not dealing with the population. We don't care about the population. You're only going to focus on the sample. Okay. So when you describe the data, describe the sample, how are you going to describe it? We have two different ways. One is using graph. One is use numeric values. Right. So to describe in a graph, basically you need to understand describing sample, it's just like describing variable. Right? So for different kind of variable, you use different kind of technique to describe it. So what kind of variables are there? In general, we have numerical variable, and we have categorical variable. So then for numerical variable and categorical variable, basically any variable that has numerical format and also it makes sense to do calculations, that's numerical. And everything else is categorical, right? Then for numerical, you can have two subsets, discrete versus continuous. And for categorical variable, we have nominal versus ordinal. So you need to be able to identify if a variable is what kind of variable, if the definition of the variable is given. So, practice on that. And then if you realize a variable is a numerical variable, then we can make some chart just specifically for numerical variable. So for example, we can make stem plot. We can make a histogram. We can make a box plot, right? We're talking about a single variable right now. Okay, for a single variable. So I need to understand how to make either of the chart, any of the chart, and also, what does the chart tell us? How do you interpret the chart? Okay, so for example, if you look at the histogram or stem plot, we know we can focus on some features like center, like spread, like shape, like mode, and outliers, right? So the 5 common features we look at. So I need to understand, how to identify these very quickly from any given histogram or stem plot. Okay. So out of these 5 common features, 2 of them are very, very important, center and the spread. Okay. So we always talk about the center and the spread for any data set. When you describe any data set, you always describe the center and spread. So in the class, we focus on how do we calculate the center and the spread, right? So for center, we use mean or median. And for spread, we use standard deviation or interquartile range, right? So you need to understand how you're supposed to find, all of these measures for any given data set, okay? So median and the interquartile range are not as often used. So we use mean and standard deviation all the time. So I'm gonna copy down the formulas for mean and standard deviation. So, just kind of give you a quick refresh in terms of the calculations. Right. So make sure you're able to find a mean and standard deviation for any data set, because we're going to use them all the time. Center and the spread. Mean is a measure of center. Standard deviation is a measure of spread. Okay. So this is for a single variable. Right. So then sometimes we're not just interested in one variable alone. Sometimes we want to try to study the relationship between variables. Like, cars weight and cars MPG. We know they're related, then how are they related? Like cars MPG and cars speed on freeway. What will be the relationship between them, right? Like, sometimes you want to see if the yield of crops, how is it related to the water amount you apply to them or fertilizer amount? Anyone have any questions? Right, so in that case, if you want to study relationships, we have two variables trying to describe at the same time. Okay, so then we can describe it using graph. The graph is called a scatter plot. And we can also describe it using a numerical value. And that value is called a correlation. We use small r to represent, right? So you need to understand how do I make a scatter plot for any given data set. It's pretty straightforward. You have two axes, x and y, representing the two variables you have. And then for every individual, you have two measurements on each variable. So that two value will serve as a coordinate in that xy plane. Then you put every individual in the xy plane, you got your scatter plot, right? So from scatter plot, what can we observe? There are 5 features you can get from scatter plot. You can get relationship form, relationship direction, relationship strengths, and the relationship outliers, right? And from scatter plot, it's very, very intuitive. It's very, very easy to see the major trend of the data. It's very, very useful. But the thing is, if you have two scatter plot, and they're very similar in terms of everything, you wouldn't be able to tell which one's stronger, which one is weaker in terms of their relationship. So we want to quantify this measure so that we can easily compare them, right? So to quantify that relationship, we use correlation R, okay? And correlation R can be calculated from a sample. There's a formula here, right? So if you calculate correlation from the equation here, then correlation has a few features. First, correlation is always between -1 and +1. So when you calculate correlation, make sure it's a number between -1 and +1, because there's no way you can get a number for correlation for outside of the range, okay? The largest correlation is +1. Basically, the direction is positive in the scatter plot, and also every point is exactly on the line. So the total amount of deviation is the least, it's 0. Okay, -1 is exactly the same thing, but the direction will be negative instead. And then correlation is not resistant. So when you have outlier, correlation will be affected by that single outlier by a lot, just like mean and standard deviation, right? None of the statistics we learned are resistant, except those location values, like median, quartiles, interquartile range. These are the only resistant measures. So when the measure is not resistant, that means you have to pay attention to outliers. So that's why we always need to look for outliers before you analyze your data. And then correlation is not affected by change of units. So if you measure lengths using inches, feet, centimeters, meters, it's not going to affect your correlation. Basically, correlation is unitless. It doesn't have unit. So whatever unit you bring in through the calculation, it will cancel out with each other. So correlation is not affected by units. And then lastly, very important, correlation. How do I read a correlation? Right? Correlation is going to be a number. So correlation, we read two features from correlation. So first, the sign of correlation will tell us the direction of the relationship. Okay. So if you have a negative correlation, that just indicate the relationship between them is a negative direction, right? And that's it. And then the value of correlation will tell us the strengths of the relationship. And here we need to, it's better to indicate this is a linear relationship, right? So correlation is only for linear relationship. If you have a nonlinear relationship, don't bother to calculate correlation. It doesn't even make sense, okay? Only for linear relationship. Of course, correlation is always for linear relationship, right? Then how are we going to tell the strengths then? So then if the value is close to 1, that indicate strong. And if the value is close to 0, will indicate weak. So it's kind of relative term. If we have two correlation, one is 0.7, the other is 0.5, we know 0.7 is stronger than 0.5, right? What about negative 0.7 and positive 0.5? Still, negative 0.7 is stronger. You're only going to look at the value. The value is still 0.7. It's close to 1, right? It's stronger, but it's a negative direction. Okay, that's two different features. Then for example, for any correlation, for example, R equal to negative 0.89, then you can quickly get, hey, there is a relationship between the two variables here. The relationship is negative, strong, linear relationship. So you can very quickly get that, relationship from that one number you calculated, okay, correlation. So if you're saying, hey, we can calculate correlation, it's very easy to read the information out of it. Why do we use scatter plot? Scatter plot is very critical. You can't skip it because there's one very important information we can't get from correlation is outlier, right? So if there's a data in the outlier and you didn't draw a scatter plot, you just calculate the correlation, automatically, your correlation could be affected by a ton by that outlier. So it doesn't really truly tell you the real picture. So it's going to be misleading if that's the case. So always draw a scatter plot first. Identify the relationship. If there's a linear relationship, then go to correlation. Okay. So then this is describing relationships between two variables. And there's another process for relationship. So if you know there is a linear relationship in between the two variables, then the next question will be, what is the specific linear relationship between the variables? So there is a linear relationship. Then the question is, what is it, right? Can we quantify that linear relationship? And the answer is yes, with a process called regression. Okay, so if you have a linear relationship, the general form will be y equal to b0 plus b1 times x. For any linear relationship, you have two parameters or coefficients. slope and intercept. It's the same form as what you learned in math class, y equal to mx plus b, right? So b1 is slope m, b0 is intercept b. So we just need to quantify the relationship. We just need to quantify the two coefficients. What is b0? What is b1, right? Then for any given data set, if you identify there's a linear relationship, we can always calculate the two coefficients, b0 and b1. So they're quantified. For example, if b0 equal to b1 through the calculations calculated to be 5, or maybe it's -5, and b0 is calculated to be +3, then the linear relationship we're looking for will be y equal to b0, 3, plus b1, -5 times x, right? So that will be the linear relationship you're looking for. There is a linear relationship just like this, right? Then from here, we can identify the slope, -5, that tell you when x increases by 1, y will decrease by 5, right? That's what the slope means. And then also we can look at, we can make estimations or predictions. So if x is given, you can predict y, right? And if y is given, you can predict x. You can do one way or the other. That's the most of the time the big purpose of doing regression. So you can predict something of unknown period, right? But when you do predictions, you need to pay attention to extrapolations. So you need to watch out for extrapolation. It doesn't mean you can't do extrapolation. It's very, very legitimate. You just need to be careful. Basically, extrapolation is basically you're trying to predict something outside of your sample data range. You have no idea what that relationship will be in that region, but you want to predict it based on the observed trend from the sample. Then you're making an assumption. You're assuming the unknown, region will maintain the same trend of, your regression region. So that's a big assumption. If that assumption is, is valid, if that assumption is reasonable, then doing extrapolation is not bad. But if that assumption is bad, like the classic examples we have, like humans' weight or the temperatures in Chicago, right? So then you're gonna see there's a big, big mistake in there for those predictions. So you just need to watch out for extrapolation. And the last thing we want to talk about is, for regression, you're using a perfect linear line to describe all different kind of variabilities in the data, right? So how well does a line describe data? We use a measure called R-square. And R-square is simply correlation R, take a square. Right? So whatever correlation is, take a square of it, that will be R-square. And this will tell us how well the line fits the data. Okay. So in terms of the question in the class, or in understanding what R-square is, basically it will ask you what percent of the variability in the data is explained by the regression equation. Okay, so if you see a question like this for a regression problem, The answer is R squared, right? Find it. If R squared is, if R is 8.8, then R squared is 0.64, that'd be 64%, right? And so on. So this is it for, describing data. You can describe a single variable or you describe relationship between two variables, and that's it. So we're done with descriptive statistic part, right? And then for the class, we spend a little time talking about sampling. So I'm going to briefly just talk over it. Sampling, we talk about, population and sample. So you need to be, you should be able to identify sample and the population for any research. Okay, so I still have some students struggle with sample and the population. That's very, very important concept. Make sure, you're clear with them. And then we talk about sampling process. So for sampling process, we talk about a few different samples. One is convenience sample. And then voluntary response sample. And then simple random sample. Okay, so simple random sample, that's what we focus on. We even have a table made for it, right? Called a random digits table. So please learn how to use random digits table as well. The other two sampling method, convenience, is easy for the researcher to get the data. And voluntary response sample is, the participants voluntarily join the study, right? So these are not really a random sample. They're not being randomly picked, right? So that could have a higher chance of introducing bias. You always want to have a random sample. Random sample, the chance of introducing bias is minimized, okay? But there are many, many other random sampling process as well. It's very, very complicated, okay? But we just go through the simple concepts, simple random sample. Right, and then after that, we talk about population parameter and sample statistic. So for all the values in the statistic, there are two types of values. One is related to the population. We call that a parameter. The other is related to the sample. We call it a statistic. For example, if a number is referring to population average, that's a parameter. If a value is referring to sample average, that's a statistic. Simple enough, right? So depending on what that value is related. Is that value describing the sample or population? Then you have two different type of numbers, statistic versus parameters, right? So anytime when you do calculations and you calculate something, that thing is always called a statistic, because anytime you calculate something, that something is coming from your sample, right? So that's a feature of the sample, not the population. And then we also talk about observational study versus experiment study. Right. So you should be able to identify if a study is observational study or experimental study, depending on how they design the experiment. The main thing you look at is if the researcher has applied any condition to the individuals in the study. So basically, are the individuals being managed to do something differently from what they do in everyday life, right? So if there is interaction or instruction from the researcher to the individual, there is interference, we call that an experiment. If there's no interaction at all, then that's observational study, right? And only observational study, only experiment can cause, can have causation. Okay, so if you want to conduct a study to prove your point, to explain something is caused by something else, it's better to go as experiment, so people can trust you more. Right? Observational study, there are too much uncertainty, in there. It's hard for people to believe you. Okay, but a lot of the study has to be done in observational study, because most of the time when your condition to apply to subjects are harmful, so when you do a human subject study, you can't do experiment. You can't experiment with people. It has to be observational study. So in that case, you have to have a few studies leading to the same direction, so they can prove each other. Then people can start to believe it. But a well-designed experiment can stand alone. It doesn't need, necessarily have to need another proof, right? But it need to be a well-designed experiment, okay? So that's observational study and experiment. And there are a few other things in that chapter. You need to understand explanatory variable, and the response variable, and subject, and factor, and treatment. So understand what each of the term means. For a paragraph describing the experimental design, identify each of those and use your own words to see, to show what they are, right? That's all I'm asking. Okay. So let's talk about that. That is about, how the experiment is designed. It's kind of a whole process, right? Okay. So then, other the inferences, we have to learn probability and distribution. So that's where we went next in the class, right? So we went to probability and distribution. Let me go to a new page. So we start with chapter 10, probability and probability rules. Right, so in order to learn what distribution is, you have to know what the probability is, right? Because distribution is about probability. So there are a few terms we started: a random process, and sample space, and event, and distribution. So I need to know what each of the term means. Of course, everyone need to know what the probability means, right? Okay. So these are basic definition in order to know what the probability is. If you understand what the probability is, now we need to talk about the rules, right? So 5 rules. First rule, for any event, the probability of that event need to be always between 0 and 1. Okay, so probability of event A is always between 0 and 1, including 0, including 1, right? That's the smallest and biggest probability. And then for a sample space, the probability of entire sample space always equal to 1. There's no exception, right? And then for addition rule, so in statistics, you're talking about the probability of events. And the event relationship, only have 2 different relationships in events, either A or B, or A and B. So that's 2 different kind of, relationship, either or and. That's the only 2 things that could connect 2 events. So if you're looking for probability of A or B, this will be by addition rule. There'll be probability of A plus probability of B. So simply add the 2 event probabilities up, okay? But this is only if 2 events, A and B, are disjoint. Okay. So I need to understand what disjoint means. Then you can apply the rule. And next rule is multiplication rule. So for the other relationship between the two events, probability A and B, in this case, we need to use multiplication rule. So I need to multiply the two event probability together. And this is only if A and B are independent. Okay. So you need to understand what the independent means, right? Disjoint means the two events doesn't have any common outcome. Independent means the two events doesn't affect each other, right? And the last rule is probability of not A will equal to 1 minus probability of A. So that's it about probability rules. Then with the rule, we can, deal with some common probability questions, like rolling a dice or two dice or, two coins or two spinners, anything, right? You can try to apply the rules to find probability of different events. Okay. And then here we introduced a term called a random variable. So random variable is a numerical variable defined out of a random process. Okay, so basically random variable is numerical. And then numerical, it could have discrete versus continuous. Since random variable could have more possible outcome, it will have a chance to be A, it will have a chance to be B, right? So then there will be a distribution talking about how likely the variable will take on each different values. And that's what distribution means. So in that case, we're going to have either a discrete distribution or a continuous distribution, depending on if the random variable is discrete or continuous, right? And that's where we talk about the specific example of discrete distribution. That'll be chapter 13. Trying to put this back. So it goes through a particular discrete distribution that's called a binomial distribution. Okay, so binomial distribution is a variable. So it's talk about a variable as number of successes out of an observation. So if x is a count variable, then x could be a binomial variable. Then how do we know for sure? We need to go with the binomial settings. So first setting is, do we have fixed number of n observations, right? And then are the n observations independent? And then do each observation, only look at one observation, give us two possible outcomes. If there are two possible outcomes, define one of them as success and the other as failure. And how do we define success and failure? Keep in mind, success is always the outcome that is being counted, right? So look at how the variable is defined. And then lastly, is there a same probability of being success for each observation? Okay, so if 4 settings are all satisfied, we can conclude the variable x will be a binomial variable with n and p coming from setting number 1 and setting number 4, right? Okay. So if you realize a variable is binomial variable, then we can do some calculations to get the probability and also population mean and the population standard deviation. Right? So for binomial distribution, we have 3 different calculation formulas. One is mean, the other is standard deviation, and then the formula to calculate the probability. This is most important, right? Okay. So that's binomial distribution. Then for word problems, you need to be able to apply the theories into the practice problems, practical problems, identify the variable of interest, identify if that's a binomial distribution. If that's the case, the event of the binomial distribution can always be calculated from the binomial formula, right? And then we move ahead to a continuous distribution, and that's normal distribution. So normal distribution is symmetric bell-shaped density curve. For all continuous distribution, we use density curve to talk about it. We started the density curve in chapter 10. We use the rectangular shape of distribution. So density curve is always going to be in 2 axes. You have x, that's the variable you're describing. Y will be probability related. Okay. So for different kind of density curve shows you different kind of distribution. So in chapter 10, we talk about a simple density curve. All the number appear just once. Then the density curve will be a flat line because this curve represents the probability of each number being appeared. So since every number appeared the same number of times, then the density curve is flat. So it's going to be the same probability. Then you can draw this anywhere in y-axis, right? So how high does h have to be? So here, there's a very important concept in density curve, and that is we use area represent probability. So anytime you're trying to figure out the probability of any event, you just need to look for the area enclosed by that event. Okay? So then the biggest sample event will be the entire sample space. So in here, we can see that probability of x between 0 and 1 will be equal to the area enclosed by the whole sample space. Right? So what will be the area between 0 and 1? That will be the probability of x between 0 and 1, right? So if that's the case, we can see that this probability need to be equal to 1 from the probability rule, because probability of any sample space need to be 1. Then we are able to figure out the height because we know base times height will equal to the area, right? And we know height is base is 1, so height have to equal to 1, right? So then in here, when we talk about normal distribution, so we talk about a continuous distribution, but it's not every variable has the same chance to occur anymore. The chances are different. So in terms of using density curve, we're going to have a density curve like this, symmetric, bell-shaped, right? Okay. So the value in the center will be mu. And the amount of the spread will be sigma, right? So then if you have 2 normal density curve side to side, this is A, this is B. We should be able to identify which one has larger mean, which one has larger standard deviation very quickly, right? So this point is mu of A, this point is mu of B. And this is sigma of A. And this is sigma of B. Okay. So it's clear B has a larger mean because it's positioned to the right for the center. B has a larger standard deviation because B has smaller standard deviation because it's less spread, right? So that's the idea of identifying normal distribution parameters, right? So normal distribution has two parameters, mu and sigma. Mu is location of the center, and the sigma is amount of the spread. We just talked about it. The most important is how do we find probability in normal distribution? So first we go with 68, 95, 99.7 rule. So basically, if you have a normal distribution, then within one standard deviation, the probability in the middle will be 68%. Then if you draw two standard deviation from the center, mu, if you measure two standard deviation on both sides, the middle probability will be 95%. And if you draw three standard deviation from the center, the middle probability will be 99.7%. Right? So with the empirical rule, we can find, a lot common probabilities if the event is bounded exactly by the 7 marks, right? For example, if X is normal with 115 as a parameter, mu and sigma, then probability of X greater than 115 will be what? So draw the density curve. 100 is here. 115 is here. So the area you're looking for is to the right, right? So then we start to use the rule. We determine the distance from the center to the boundary. That's 15, right? From 100 to 115. So that's exactly one standard deviation away. So this is one standard deviation. Then we need to use the 68 rule to figure out. So from 68 rule, that means the middle probability, if you go both way, one standard deviation. So that will be 68%. Then the total distribution is separated by 1, 2, and 3. They have to add up to 100%. Then 3 is what they're looking for. If we use a variable x represent, and this x is different from that x. So that maybe that's not use x, let's use a represent. Okay, that means a, because piece 1 and piece 2, piece 3, they are symmetric. They have the same area, so they have the same probability. A plus A, right? And OSP is 2 probability. That's 68% by the rule. So then we just need to solve a simple equation to figure out, the probability of interest is 16%. And that's the answer, right? So pretty quickly, we can find probability of some specific event. But the use of the empirical rule is very limited, because if you try to find a probability that's not bounded by those 7 marks by the rule, then you can't use the rule anymore, right? You don't have the symmetry to figure that out. So in that case, we learned a tool by defining a special distribution, Z distribution. Z distribution is normal 0, 1. So for any normal distribution, we can convert it into a Z distribution. Then we make a table for it called a Z table. So you can find the probability of any normal event probability from Z table. And for axes, for any other distribution, normal distribution, we can simply convert it into Z distribution by a standardization formula, Z equal to X minus mu divided by sigma, right? So from here, all the axes will be standardized into Z. Okay. And then you can use the rule if the condition is met. That's the case. So basically that's it. Make sure you know how to find a normal event probability for any normal distribution. And also based on probability, you can find a cutoff point, like what is the top 2% cutoff? What is the bottom 5% cutoff, right? So that's the 2 different ways of using Z table. One is from Z to probability, or from probability back to Z, okay? That's normal distribution. So then we're very close to finish with the probability and distribution part. We just need to have one very important theorem. That's called the central limit theorem, right? So for sampling distribution, maybe chapter 11. Okay. So first, understand what's a sampling distribution. Sampling distribution basically is talking about distribution of a sample statistic with the same sample size due to random samples. Okay. So if you look at the picture here, when you take a random sample out, right? So here, from here, we can calculate a sample statistic, X bar. You can calculate sample standard deviation, S. So then this is just from one random sample with any sample size. For example, you can set sample size n equal to 10. But if you think about all the possible samples with sample size of 10, you have so many individuals in the population, there are many other possible samples as well, right? In that case, you can calculate a different sample mean and a different sample standard deviation, right? And so on. You have many different sample means. There could be a sample mean of a random sample you choose. Then how likely will the sample mean be to be this value versus that value, right? What is the distribution of sample mean X bar? And that's sampling distribution. So for any statistic, it's gonna have a distribution. It could take different values. So that's distribution, okay? That's sampling distribution. Then we're gonna focus on the sampling distribution of sample mean, basically. So that's given by central limit theorem. And from central limit theorem, we learned that if sample size is large enough, sample mean x bar will always follow a normal distribution. And it is the central limit theorem that make normal distribution the most important distribution in statistics. Basically, it doesn't matter what kind of population you're studying. When you draw a sample, if your sample size is large enough, your sample mean x bar will always end up with a normal distribution. So you can use normal distribution to solve any problem, any data analysis. All you need to have is make sure your sample size is large enough. So the normal distribution is like a universal tool for any kind of problems you're dealing with, if you can manage a large enough sample size. Okay. So that's central limit theorem. So basically, there are a lot of questions in central limit theorem. Basically, the question will be asking for probability related to x bar event, right? X bar greater than something, x bar smaller than something. Then you just need to find the distribution of x bar first. And then the same as any normal distribution problem, right? Standardize and look up on the Z table, okay? So that's chapter 11, central limit theorem. And now we are done with all the probability and theory part. So we go back to the population inferences. So how do I make inferences, okay? So this is the last piece of the puzzle now. Right, so now we're gonna focus on inferential statistic. Okay, so here, inference, what's the inference? Inference is a process to draw conclusions toward the population. Okay, so if you're trying to draw a conclusion toward a population, inevitably, you have to do an inference, okay? So in general, there are two types of inferences. One is confidence interval. One is hypothesis test. And we went through both of them, right? So they have different purpose. In confidence interval, we are trying to estimate a measure of the population. So there's an unknown population. There's some feature you want to know about it. Mostly it's population mean, but sometimes you want to estimate their population standard deviation or population variances, or doesn't matter. Basically, if you want to do an estimation of it, you need to do a confidence interval. Okay. Now, on the other hand, if someone make a claim about a population, like if I'm saying, I think the average debt of MSU students is higher than $30,000. So there's a claim. Then how do we know if that claim is true or false? You need to assess that claim being true or false. Then you need to go through a process called hypothesis test. Okay, so you need to really understand the differences between confidence interval and hypothesis test, right? If you're trying to make estimations, confidence interval. If you're trying to assess a claim, hypothesis test, right? Okay. So then for confidence interval, we learned two different process of confidence intervals. One is Z confidence interval, a confidence interval using Z statistic. One is T confidence interval. It's basically a confidence interval using T statistic. So they're being used both, but you need to understand when to use which, right? So the condition for both confidence interval need to have random sample and the sample size large enough to apply central limit theorem. And then the third condition will be different. That's the key. So for Z confidence interval, you need to have a known standard deviation, sigma. Okay, so sigma has to be a value provided. You are not expected to calculate sigma. Sigma need to be something that you know of, right? And of course, if you don't know the population standard deviation, then you're stuck with T. You can't do Z anymore because you don't have that sigma, right? So make sure you understand the differences. And the work about them is very simple. Just identify each of the values. What is X bar? What is Z star? What is sigma? What is N? And calculate. You can have two numbers calculated, a small number with the subtraction sign and a large number with addition sign, right? Then you just draw a conclusion. So we have C% confidence that the average, whatever measure you're interested in of the population is between the small number and the large number. And that's it. You just need to change these parting codes into the context words. So basically, all the inferences require you to write a conclusion. A conclusion is a sentence using plain language so that anyone can understand after analysis what your finding is, right? So do not use any statistical term in there. Do not use null hypothesis, alternative hypothesis. Do not use population, right? Use common words using context words. And that's the process of it. It's pretty straightforward. And there's something you need to pay attention to is there's a term called margin of error. Right? So what's margin of error? Margin of error is the term after subtraction and addition on both confidence intervals. Right? So both of these two terms are called margin of error. You have margin of error for Z confidence interval. You have margin of error for T confidence interval. So most of the time when you do confidence interval, when you make estimations, you want your estimation interval to be small. So it's more, beneficial or helpful for people to make a decision. For example, when you estimate a laptop price, do you want to get an estimated price between $1,400 and $1,500? That's a narrow range. Or do you want to have estimation between $1,000 and $2,000, right? So which estimation range will help you to make a better decision? Of course, you want to have a narrow confidence interval, right? So the confidence interval basically is determined by this margin of error. Basically, for all the confidence interval, the center point is going to be X bar. And now each side, when you calculate the two boundaries, you either add or subtract the same thing, right? And what is the thing you add or subtract? That's the margin of error, MOE. So your confidence interval is always twice as big as margin of error. If you want to reduce the confidence interval, reduce your margin of error. And what is the best way to reduce margin of error? Of course, the best way to do it is increase your sample size, right? Okay, so that's confidence interval. Now we go to hypothesis test. Okay, so for hypothesis test, we learned quite a few different hypothesis tests. So let's get all of those here. Well, before we move there, for all the hypothesis tests, we need to follow the same 5-step procedure. So please make sure you're familiar with the 5-step procedure for hypothesis test. Every step is required in the test, right? Make sure you don't miss any step, otherwise you're gonna get points deducted. So first step, state hypothesis. Hypothesis is the research goal. So basically, what is the claim you're trying to evaluate to be true or false? That claim is your hypothesis. When you state hypothesis, you need to state both null hypothesis and alternative hypothesis at the same time. Okay? The null hypothesis is a claim stating something being the same, alternative hypothesis stating something being different, right? So the null hypothesis always have equal sign. There's no exception. And the alternative hypothesis, you could have different kind of different signs. Smaller than is a type of different, greater than is another type of different, and not equal to will be the third type of different, right? They're all different kind of difference. Right, so first step, stating hypothesis. Find a research goal and state it using, symbols, null and alternative hypothesis. And the next step, it seems to be trivial, but you need it, right? I see a lot of students skipping this step. I will take out points if you don't write it. State rejection rule. Okay. So the rejection rule is always one simple sentence. If P is less than a value, then reject the null. Okay, it's very simple. It's it sounds trivial, but it's important. Okay, what is that value? That's alpha. Alpha is type 1 error rate, right? So by default, if I don't give you what alpha is, use 0.05 in the class. Otherwise, just use whatever is provided. So that's the error rate. So you have to understand the type 1 error and type 2 error. So if you ever confuse with type 1 error and type 2 error, always think about the trial process. There's some defendant in a court, and the judge will need to decide if that defendant is guilty or not guilty. The truth is, the defendant could be innocent, could be guilty, depending on if he committed the crime or not. But the judge and the jury are going to make a decision about the person is guilty or not based on the evidence. So they're going to decide if that person is guilty or not, right? So in that case, you can have, different possibilities, right? So if the person is actually innocent, but the judge and jury decide he's guilty, the judge and jury is making a mistake. And that mistake, we call it a type 1 error. We, in analysis, in hypothesis test, we are the judges. We are making a decision, and our decision could be correct, could be incorrect. When our decision is incorrect, then we committed error, right? And that's what the type 1 and type 2 error is. So in general, type 1 error is when you reject the null hypothesis, when the null hypothesis is actually true. Type 2 error is when you fail to reject the null hypothesis, when the null hypothesis is actually false, right? But I'm going to ask you guys to write explain the type 1 or type 2 error in the context words. So the general word is very, very simple. Everyone can memorize it. But if you can't convert it to the context words, you don't really understand what you're talking about, right? So try to think a little over it. It just needs some time to do the thinking so you understand what the type 1 and type 2 error is. So for all the analysis, all the hypothesis tests, we have a chance for error. Why do I still bother to do it if we can't make it 100% correct? Well, that's the thing. You can never be 100% certain in statistical analysis. There's always chance for error. But the thing is, the advantage of it is we can control the error rate. So if you control the type 1 error rate to be 5% and you reject the null at the same time, then that means you have 5% of chance to commit an error, but at the same time, you have 95% chance to be correct. So we can maintain an advantage of being correctness over that we're committing errors. So we have a higher chance to be correct when you go through the hypothesis test problem instead of just random guess, right? Right, so that's step 2, stating rejection rule. Trivial, but important. And step 3, calculate test statistic and find p-value. Okay. So the ultimate goal of step 3 is find p-value. But where the p-value going to come from, that depends on what kind of test you do, right? If you do a z-test, you need to calculate a z-statistic, then the probability of p-value will come from z-table, from z-distribution. If you do a t-test, the test statistic will be a t-statistic, then the probability for p-value will come from t-table. And in the future, if you take an advanced stats class, there's going to be an F statistic corresponding to F table, a chi-square statistic corresponding to chi-square table. So, you have different kind of distributions to work with different kind of problems, right? So that's step 3. Step 4, apply rejection rule to make a decision. So you find what the p-value is in step 3. You define what alpha is in step 2. You have both values and ready to compare. And that's all you do in step 4. If p is smaller than alpha, by the rule, we're going to reject the null. If not, if p is greater than or equal to alpha, then we can reject the null. We fail to reject the null, and that's it. So that's step 4. All you do is compare p and alpha. And the last step, conclusion. So it doesn't matter if you reject the null or fail to reject the null. You need to tell people, normal people who don't have statistical knowledge, that what your finding is. And that's what the conclusion part is. So tell a story using plain language or the context words. Do not involve any statistical term in there to tell people what your finding is after your decision making. Okay? And that completes the 5-step procedure. Every step is important. Make sure you include every single step in the problem. And out of the 5 steps of the hypothesis test, the step 3 is the only step that's being different in hypothesis test. All the other steps are pretty much no different in different procedures. For example, stating hypothesis. All you need to do is find the research goal. What's the claim you're trying to evaluate, right? That's all the same, regardless what kind of test you do. Step 2, basically you just define what alpha is. Do you use alpha at 0.05 or use alpha as 0.01, right? And that's it. And step 4, you just need to compare p and alpha. You find p in step 3, you have alpha defined in step 2, you compare them. And step 5, telling a story, right? So the only step being different is step 3, calculating test statistic and find p-value. Then for different hypothesis tests, we have different formulas to calculate the test statistic, and we have different tables to find the p-value, right? So in the in the class, we have a few different test procedures we went with, and we're only going to talk about the step 3 here because other steps are exactly the same. So we have one sample z-test, one sample t-test, paired t-test, and pooled variance t-test, right? So first thing you need to understand when to use which, right? So it's clear, very easy to see if it's one sample problem or 2 sample problem, right? So get a good, get it very quick. Is it 1 sample or 2 sample problem? If it is 1 sample problem, you need to choose between z and t, right? And how do I choose it? The same as the common interval we learned between z and t also. So if you have known sigma, you need to choose a z process. If you have an unknown sigma, you need to do a t process. Right? Keep in mind, sigma is population standard deviation, right? S is sample standard deviation, okay? Make sure you can tell the differences. Is it a standard deviation of the population or standard deviation of the sample? So if you have a known sigma, you choose z-test. If you are unknown sigma, you choose a t-test, and that's it. And then if it is two sample problem, then you need to see if the two samples are being dependent or if the two samples are independent. Right? So I need to understand dependent independent term in terms of two group values. So dependent mostly referring to if the two groups are measured from the same individual, like a before and after workshop student scores, it's the same student being measured. Of course, the score will be related, right? So they're dependent. Or if the two group samples are coming in pairs, like husband versus wife, like twin brother versus twin sister, right? So they come in pair. There's some kind of relationship between them to affect each other. In that case, they are dependent. And to independent case, this means the two groups has no relationship whatsoever. Whatever value you see in group one is not going to affect the values in group two. They're not going to affect each other. That's independent. Okay. So if they're dependent, you need to choose a procedure pair t-test. If they're dependent, it's pair t-test. If they're independent, that's pooled variance t-test. We have another procedure mentioned but not required called a Welch's t-test. That's also for independent samples, but the calculation is a little bit more involved, complicated for the degrees of freedom. We don't require that Welch's t-test, right? We're only going to look at the pooled variance t-test because the calculation is easier. And then for any hypothesis test, you need to follow exactly the same 5-step procedure, but you need to determine what test you need to do first, right? Okay. And then that's it. And write a conclusion by the end, don't forget. And realize you have two types of errors, type 1 error and type 2 error. And that's about it. That's basically the hypothesis test. So right now, we basically went over everything we learned so far for the whole semester, but it's very, very brief. I didn't go into any details. If anyone have any questions, for any concepts here, please contact me. We have another Zoom meeting tomorrow at 10. That will be question and answer sessions. Please bring your questions. If you can't make it to that time, you can always make an appointment with me. Just send me an email, and sometimes we can communicate with email as well. But it's always better that we can communicate instead of writing in emails. So I prefer Zoom meeting. That will be more beneficial to you as well in terms of getting my explanation well. All right. So unless you have any questions, I'm gonna stop right here.